Thank you very much for being here this early on a Sunday morning. I'm going to be talking about JSON Web Tokens and how to do some authentication with single-page applications. Who of you has used JSON Web Tokens before? Okay, most of you. Now keep them up. Who knows exactly how they work, JSON Web Tokens? Yeah, I guess some people do, but I saw some hands going down. I hope that after this talk you have a better insight or sense of how they work and how you can use them. And how you can use them, especially with single-page applications, because this is a JavaScript conference. I assume a lot of you are doing JavaScript on your day-to-day basis. Single-page applications, it's very hot in JavaScript. React, Vue, Angular, whatever. It's Sunday, 9 o'clock. I hope you all are awake. I'm kind of awake, but just to wake up, we have some stretches we can do, some morning exercises. You can try this if you want. It's a bit difficult here on stage, but that's enough of being ridiculous. My name is Sam Bellen, and I'm a developer evangelist at Auth0. If you've never heard of Auth0 before, we're an identity as a service provider, which basically means that we try to make it as easy as possible, or as possible for everybody here in the room to implement a secure authentication flow, so you can focus on building your actual products, your actual apps, and don't worry about the authentication. I'm a Google developer expert, and I organize a few meetups, one in Belgium, Frontiers, front-end related, and one identity and security meetup in London. If you're ever in Belgium or London and these meetups are happening, please join us, it's fun. And you can find me on the internet as Sam Bagel. So, I have cat stickers. If you want cat stickers, who wants a cat sticker? Nobody? A few people? Send me a tweet of a cat or a dog or a bunny rabbit or any animal you can think of, and I'll give you some stickers after this talk. What we're going to be seeing today is traditional authentication, or at least what I consider traditional authentication on the web. We're going to see what a token is, more particularly a JSON Web Token, and we're going to look into token-based authentication with single-page applications. All right, traditional authentication. To me, traditional authentication is a system where you have a website which is completely generated on the server. It's these classic languages like PHP and stuff which do all the logic on the back end, and they just generate an HTML page, send this to the browser, and the browser renders this. But there's not really that much logic going on in the front end, which means that also the authentication is handled on the back end. And that's a big difference with the single-page applications of these days. We're going to see the differences later. But it usually happens something like this. You have a user, a browser, which does a request to a server. And if the user wants to access a protected page, a page for which the user needs to log in, the user is going to type in username, password, or whatever. Browser is going to send this to the server. And if the credentials match, the server is going to just say, OK, you're allowed to see this page. Here is an HTML page. Render this browser. But it's usually also going to set a cookie, a session cookie, just so that the user does not have to send the credentials, the username, password again, and again. Because if you would visit a website and for each page you want to visit, you have to log in again, that would be super annoying, right? So the browser is usually, or the server is usually going to send a session cookie as well, which can contain a lot of things, but usually a session ID. And the next time the user wants to access a protected resource, a protected page, the browser is just going to say, hey, I have a cookie for you. Maybe you can do something with this. The server sees that in this cookie is a valid session token or session ID, and it's going to just send you the page anyway, so without you having to log in over and over again. Does this sound familiar to a lot of people? It's how we've been doing this on the web since kind of forever, or as long as the web exists, whatever is longest. But there's some differences between these traditional web apps and single-page applications. A traditional architecture, often it's just a server. This can be a whole farm of servers, but a backend that does most of the logic, authentication, business logic, whatever, and it just serves HTML pages to the browser. It's usually this one-on-one relation, even though you can have a bunch of backends talking to each other in the back. Doesn't really matter. Single-page applications can be something like this. Your single-page application lives in a certain domain, does requests to a certain API, does requests to another API for some user data, does a request to another API for some payment processing, and so on and so on. So if you're doing these single-page applications, often they make requests to different domains, different origins, which is not always the case with a traditional architecture. And you can also have something like this, a mobile app, a desktop app, a single page application, and they all talk to the same API. Who's working or has worked on a scenario like this before? I see a lot of hands. Now the funny thing is, only the web uses cookies to remember this session state. A mobile app does not use cookies. A desktop app does not use cookies because cookies is something inherently for browsers and the web. So it would be nice if we could do this state management and this credential saving thingy more or less the same for all of these apps, because they all just talk to the same API, which gives us data which we can then use, or we can send the data which the API will process. So some of the problems with this traditional cookie-based approach: cookies do not like CORS. Who likes CORS? You're lying. Nobody likes CORS, because if you have a CORS problem, what do? You go to Google and you type, I have a CORS problem. You end up with Stack Overflow, and there's this one answer of this one person in the world who knows how CORS works, and it just answers your question. Nobody likes CORS, including cookies. Cookies require state, because most of the time in these cookies, these session cookies, you have a session ID, which is saved in a database and has some other properties together with that ID in the database. But with modern APIs, we would like to have them as stateless as possible. It's not always possible, but we try to. But cookies usually require some state. And cookies don't flow. A cookie issued by a certain origin or certain domain cannot be used by another origin or domain. So if your main API issues a cookie with a session ID, it cannot be used by your payments API, an external API, your authorization server, and so on. So you cannot pass them from server to server. For example, something like this. So what's the solution? Maybe it's token-based authentication. We'll discover this throughout this presentation together. We'll see. But first we need to see what a token is. And to me, a token is a unique identifier representing something. There's a whole different bunch of tokens. We'll see a few of them. We see some few examples. But anything can be a token as long as you can take the token and get some meaning out of it. If it's an ID of something stored in your database, it's a token. If the token itself contains a lot of information, it can also be a token. And there's a few different ones. Access tokens. Who's used an access token before? Some hands? Okay. An ID token. Who's used an ID token before? Some hands again, a few less, but still. We're going to see them, so don't worry if you've never seen them before. A refresh token. Again, some hands. Cool. And they're often an opaque string in the form of a UUID, which means that they're a unique ID, again, pointing to some records in your database. But they don't have to be. They can also be SAML or XML. If you use a SAML protocol, your token is a whole bunch of XML which contains some information, but it's a bit dated. So it's very nice that you have this XML file or blob with a lot of information, but nobody likes XML on the web anymore. We all like JSON, right? So it can also be a JSON Web Token. And a JSON Web Token, like it says, it's mainly just a bunch of JSON. At Auth0, we use JSON Web Tokens as much as possible, just because we like them. That's why. And this is a JSON Web Token. And if you look at this token, it kind of looks like a bunch of random numbers or letters or symbols or whatever, but it's not. If you look closely, you see three different parts. You see the first part in red, then you have a dot, the middle part, the biggest one, a dot, and then the bottom part, the blue part. So there's three different parts, and they're separated by a dot. A JSON Web Token will always have these two dots separating these three parts from each other. So it looks like random data, but it actually is not. The first part, this one, is actually just a base64 encoded JSON object. So if you would take this first string and go to base64decoder.com or whatever you have, and paste it in there, you would get some JSON, something like this. And the first part is called the header, and what this is basically some metadata about the token itself. It says the type, I'm a JSON Web Token, obviously, because we're working with JSON Web Tokens. But it also says the algorithm that's been used to sign the token. We're going to see the signature later, but it already tells you, like, if you want to verify my signature later, please use this algorithm, in this case, HS256. The second part is called the payload. And again, this is just some base64 encoded JSON. If you decode this, you get maybe something like this. And the payload is very interesting because it contains a lot of information for the consumer of the token. If you're an API and you want to consume an access token, it contains some information about which things you can access on that API. If you're an ID token and you want to get some more information about the identity, it contains some things like your given name or your family name or your preferred username and when it's issued at. And also very important, you can include an expiry date. So just from looking inside of the token, you can already see if the token is still valid. Because tokens usually give access to an API or something, so you don't want them to be valid for a long time out of security thingies. So they expire reasonably fast, but you can already see from looking inside the token when they expire, if they are still valid. And there's a bunch of different claims you can put inside the payload. A claim is just a key-value pair. Reserved claims are the ones which are specified by the spec of a JSON Web Token. Subject is usually your user ID, issuer, the API or whatever, the authorization server that's issued the token. When it's issued at, when it expires, there's a few others, but these are all specified by the JSON Web Token spec. The second one are public claims. And these are not really specified by the JSON Web Token spec, but they do have some kind of standard. There's the IANA, which is an organization on the internet which tries to standardize certain things, and they have made a list of a lot of claims you can use in a JSON Web Token, and they try to standardize this just so that every API would call these claims the same. Given name instead of first name, family name instead of last name. If you know that all APIs don't have to, but try to implement these standards, you can assume that an API built by him and an API built by you all return your family name as family name, not as last name or whatever you have. So there's a whole list of those. Not mandatory, but it makes API interoperability easier. And then there's a third set of claims. These are private claims, and basically any valid JSON can go here as long as it's useful for the consumer of this token. So if you want to put a super huge array or something in there, go ahead and do it. But I doubt that it will be very useful for the consumer of this token. So only put stuff in here that's useful. Another note, I told you before that this is just a base64 encoded JSON object, so don't put anything sensitive in there, don't put credit card data or anything, because we all know how to decode base64, or we all know some tools that can do this at least. So keep it relevant and don't put anything sensitive in there. And then the bottom part, we've seen the header, we've seen the payload, is a signature, and it's very interesting. The signature is basically, you take your header, you take your payload, you take a signing algorithm, in this case it's HMAX SHA-256, or whatever you want to pronounce it, and you take that data, you run it through that function together with a secret for this algorithm, and you get a signature. This means that if something changes in your header or your payload, your signature will also change. So you need to update your signature every time you change something of the payload, which means that you can verify that the data inside of those payloads, if that payload is valid. If it changes, the signature needs to change, but in order to change that signature, you need to know the secret in this case, we'll see, or you need to have a certain private key with some other algorithms. So the signature lets you verify the content of your JSON Web Token. JSON Web Tokens can be verified. Your super secret key is usually something a bit more random. So if we look at this in practice, we have some JSON, we take a base64, some JSON, we take a base64, and we just run it through an algorithm with the secret. And we just put all of those parts together, we get this. And this is a JSON Web Token. If you would go to JWT.io, which is a website we built, but you can basically just use it to debug JSON Web Tokens. Paste it in here, we see that the payload, my subject 16 and my name, is missing a space because I made a bug, but it contains the data we wanted. The signature isn't valid because we signed it with the secret. So if you would type secret here, paste it again, our signature is verified. So we just verified the signature based on our secret, which we used earlier, and we can see the content of the payload and the header. So yeah, a JSON Web Token, just some base64 and a signature. That's all it is. But let's look at some real-world examples. An access token, I've asked before if you've used it. A lot of people said yes. If you've never used it, it's basically something you use to authorize yourself with an API. If you want to access a certain endpoint at an API, chances are you need to be authorized to do that, and you usually send along an access token. So this contains some information which is usable for an API. The audience, which API needs to use this token. The scopes, what can the user authorized with this token do on this API? Sometimes you can only read stuff, or you can only write stuff, or you can only see certain endpoints, and others are not allowed. So this will go into your scope. Again, there's an expiry date, issue that date, and the issuer, your authorization server. But an access token will always contain a lot of information useful for APIs. An ID token, on the other hand, contains some information about the person who authorized. So it's all identity-related information, like your nickname, your name, maybe your avatar as well, and in the end also an expiry date again, so we can verify its expiry date. If you want to do this in JavaScript, looks a bit like this, but there's a lot of libraries which generate these tokens for you. And we've seen this with asymmetrical algorithms, an algorithm that just takes a secret and uses that secret to create the signature and verify the signature, which is okay. There's also asymmetrical ones which use a private key to generate the signature and a public key to verify the signature. There's a whole bunch of different algorithms. I'm not going to go through all of them. There's even more than the ones I've written here. But basically what they do is they have a private key to generate the signature, a public key to verify it, and you give this public key to any instance that needs to verify the signature, but you keep the private key so only you can generate the signatures. So if you want to share this public key, you need to share it. You sometimes need to share it with external parties as well. But since it's a public key, it can only verify, it cannot create a signature. It's okay to share them. You can do this in a whole bunch of ways. One of them is a JSON Web Key, which is again some JSON with some information about the public key. If it looks like Chinese to you, that's fine. People who need to verify things with public keys know what this means. The important thing is it's JSON, and you can share it with anybody who needs to verify your tokens. And these are often exposed publicly at some kind of endpoint of your API or of your authorization server. If you use OpenID Connect, they're at your authorization server /.wellknown/OpenID configuration. If you go to that, you see a lot of information, and one of them is a JWTs URI. And if you click on that, basically it contains all the public keys you can use to verify signatures created by this authorization server. You end up on this URL. So JSON Web Token, JSON Web Key. There's also JSON Web Signature, which is basically the bottom part of your JSON Web Token. There's also JSON Web Encryption if you want to do some encryption on the web, or anywhere actually, based on JSON standards. I'm not going to talk about this because I would be here until my flight leaves this afternoon, so let's not do that. But there's a lot of standards based on JSON because these days we like JSON. So let's make a little comparison. We have the header of a JSON Web Token on the left. Algorithm is this. The type is I'm a JSON Web Token. And on the right, we have the front of my passport. I'm Belgian, so it's written in 4 languages because why not? But what it says is I'm a passport of the Kingdom of Belgium issued for the European Union or by the European Union. And that's kind of the same thing as the header of a JSON Web Token. It tells you what it is. It's a JSON Web Token. It's a passport. The payload tells you some more information about for the consumer of this JSON Web Token, an API or the identity. The same thing if you open my passport, you see some information like my picture, my name, my last name, but also the expiry date of the passport. The same thing goes for a JSON Web Token. Some claims and the expiry date of the JSON Web Token. And then again, you have your signature to verify the content of it, and most passports have some measures in place to verify that it's a real passport and not something I printed at home quickly to just go to another country. So in essence, a JSON Web Token is nothing more than a passport that can be used by a certain party, an API, yourself, whoever you need, you want to use that token. So let's see it in action. I have this really complicated app which has a few buttons. The first one lets me see dog pictures because, well, I like dogs. which is fine. But we also have a button that lets me show cat pictures. But as you all know, cats are a bit more difficult than dogs. So for to see cat picture, I need to authenticate because not everybody can see these cat pictures. So I'm going to log in quickly with Google because that's easy. And by logging in, we've done a few things. I used Auth0, but it doesn't matter which identities provider you use or if you have your own system. But we've done a few things. We authenticated, so I sent some credentials which matched, and we got some things back. We got back an ID token and an access token. And as we've seen before, an ID token contains some information about the identity of the person who just authenticates. And on the upper right corner, we can already see my picture, my username, just because in the ID token, there's that information, so we can take that information and already display this without doing an extra request to your API for some user information. You just get it for free when you use OpenID Connect and use ID tokens. But we also got an access token back, and we can use this access token to do some API requests to protected endpoints. In this case, we can request some cat pictures like these. And this is my cat. I always stop when I see my cat, so it's relatively fast. But we send along this access token, which each requests for cat pictures. If you would do this if you look at the API, we have a very simple API with 3 endpoints. One which is going to do the authentication, password, username. When you do this, you get back a JSON Web Token. Let's copy this. Then we have an endpoint to get dog pictures, and we get a random dog picture because everybody can see those dog pictures. But if we would do the same for the cat pictures, we would get no authorization token was found because we need to actually send that token. If we would, let's see, send that token as a bearer token and then do the request, we get a cat picture. So this works as expected, but some of the strengths of JSON Web Tokens are that they contain a lot of information inside of them. So if, for example, I would use a token that's expired, of which the expiry date is in the past, which cannot be used anymore, without doing too much extra things, our API can know, like, hey, this token is expired, I'm not going to accept this anymore. You will not be able to see cat pictures until you get a new valid token, just because the expiry date inside of that token is not valid anymore. The same goes for a token of which the signature is not valid anymore, which means that I tried to change something in the payload, but I didn't update my signature. If I use a token like this, it will already see, oh, the signature doesn't match the payload and the header, I'm not going to accept this. No cat pictures for you. And the same thing goes, no, it's a valid JSON Web Token we've already seen. So without doing that much extra, just by looking inside of the JSON Web Token, just by verifying the signature, we can already come up with a lot of examples of which we can just refuse the JSON Web Token, or the token in general. If you want to know more about JSON Web Tokens, JWT.io is a website which we used earlier to debug the token. It also lists a whole list of libraries that lets you work with JSON Web Tokens easier. There's also a bunch for JavaScript over here, and also contains a bunch of information about JSON Web Tokens if there's something else you want to know or you want to revisit everything I've said before. So JWT.io. So are there some downsides to JSON Web Tokens? Yeah, an invalidation of a token is a bit harder. Like I said, the tokens contain all of the information inside of it. Once it's out there, they prove their own validity, so you need to create a blacklist or a whitelist to say, I know this token is technically still valid, but I don't want to accept it because of other reasons. It's on this blacklist. So if you want to invalidate a token, a JSON Web Token, it's a bit harder than just erasing ID or a row from your database. And if you leak your secrets or your public key, or your private key, sorry, it can be a bit annoying. That's why they're private keys and secrets. That's why they're called like this. So also, don't put sensitive data in your JSON Web Token. We've talked about this before. It's just base64. We can all decode that. Don't do that. So we've seen what a token is. Let's look at a modern way to do token-based authentication with single-page applications. Again, user, browser, API, whatever. We do a request until we hit a protected endpoint, something with sensitive data. We send our credentials, If the username and password match, we get back an access token, which we can use to access that API. We save this somewhere in memory, and every time we want to do an API request to a protected endpoint, we send along this token. It's kind of the same thing as sending along a cookie, but just another way. So every time we have this token and the token is still valid, we can get our data back and show it on our website. The most important part is that you send it as a bearer token in your authorization header. So you send it as a header with every request. That's why you should keep the content of the payload as small as possible. So auth, who's ever used auth before? Auth is a well-known framework for doing token-based authentication. And what it says in the definition of auth is it's a protocol that allows a user to grant limited access to their resources. So it's made to grant access or limited access to your resources. It's not made to do identity things. It's not made to do authentication. It's only authorization. But we kind of misuse it a lot on the internet as also a way to do identity authentication. But there's something else for that. If you want to do token-based authentication with identity, there's OpenID Connect. And basically what OpenID Connect is, OpenID Connect was created as an identity layer for OAuth 2.0. So you take everything that's specified in OAuth 2.0 and just add this extra layer of identity on top, which is the ID token we've seen before. So if you want to do identity, if you want to do authentication with a token-based approach, chances are you want to be using OpenID Connect and not OAuth. So let's look at an example. I've split my authorization server apart just for some illustrative purposes. Is that a word? I'm not sure. It's Sunday morning, so let's say that's a word. So we do a request. We send our credentials to our authorization server. If the credentials are valid, we get our access token back. But we can also get back an ID token if you want to, and a refresh token if you really, really, really want to. More about that later. But we get back a bunch of tokens from our authorization server, and we save them somewhere in memory. And we use this access token to do other API requests to all the other APIs that we want to be using. And if the token is valid, we get our data back. So I've said before, we save these tokens somewhere in memory. Does this mean that every time the user revisits your page or refreshes, your memory is gone? Does the user have to be logging in again? That would be annoying, because we're not saving these tokens somewhere persistently. And if you would look at all of these things on the internet, a lot of blogs and tutorials would tell you to save tokens somewhere in local storage or in a cookie. But that's not always the best idea because of cross-site scripting and stuff like this. Once somebody has access to your token, they have access to your API, and we don't want this. So for this example, we're going to save the tokens somewhere in memory, use them as long as they are in memory. But if we want to persist them in a certain way, we do the same. We send our credentials to our authorization server, get our tokens back, and we get a cookie back. So we're back to a cookie-based approach. But this cookie, it's an HTTP-only cookie. We can safely store in the browser. And the next time the user visits your website or when it refreshes, we send this cookie through an iframe in the background and do a silent authentication request is what it's called. So basically, we're sending this cookie to our authorization server. It's issued by the authorization server, so you will not run into course problems. If the ID in this cookie matches in the background, you'll get your tokens, and you can do whatever you want. So the first thing you do when you start up your single-page application, when you bootstrap, is do this silent request, get your tokens, and as soon as you have your tokens, you can use them to do some requests. This avoids you having to save your tokens somewhere persistently, and avoids them being stolen by cross-site scripting, for example. This example uses the OAuth implicit flow. If you're familiar with OAuth, there's a bunch of different flows for a bunch of different scenarios going from mobile, desktop, and the web. And single-page applications always used to use the implicit flow just because it's a very simple flow. You send your credentials to your authorization server, you get tokens back, ta-da, it works. But there's some issues with this flow, and the IETF, the Internet Engineering Task Force, I think it's called, they published a best practices document in almost a year ago, I think December last year, stating that you should not use the implicit flow. And if you use this, don't start to panic, because if you're using this, chances are you already mitigate most of the risk involved with this flow. but they do propose to use another flow, which is the authorization code with proof key for code exchange, PXE for short flow. It's a bit more complicated. We do the same. We send our credentials, username, password to our authorization server, but together with this, we send a code challenge. Let's say that this is a random number. It's a bit more complicated, but let's call it a random number. The authorization server is going to save this challenge and is going to send another random number to your browser. We're going to take this, sign this in some certain way, and send that code. The authorization server send this together with a verifier back to the authorization server, and by comparing the initial challenge and this code verifier, we can verify that the party that's requesting this tokens is the same one that initiated request. So by just comparing this code challenge, the returned code, and the code verifier, the authorization server can be certain that whoever is asking access to certain resources is the one that has started the initial request. So it's a bit more safe. It's 2 more steps, but chances are you're using a library to do authentication anyway, and they are starting to implement this flow. We as well with Auth0. And if everything is okay, you get back your tokens, and we're back to where we were. So the rest all stays the same. It's just your initial authentication is a bit more complicated. So a note about access tokens as JSON Web Tokens. An access token does not need to be a JSON Web Token. The auth spec does not specify what an access token should be. It can be a string, can be XML if you really want to. It can be a JSON Web Token, but it does not need to be a JSON Web Token. There is, however, an IETF draft to standardize this. It's this, and if you look at a proposed access token as a JSON Web Token, it kind of looks like something familiar. You have your header, and it says the type. I'm an access token plus JSON Web Token, but that's the only difference. The payload is still issuer, subject, audience, expiry date, and etc. Things like this. So there's a standard, or they're trying to standardize this, but you can use anything as an access token. An ID token, however, is always going to be a JSON Web Token. OpenID Connect specifies that an ID token is always going to be a JSON Web Token containing information about the identity. Any note about refresh tokens and single-page applications? A lot of people like to use refresh tokens, but they're very dangerous to use on the front end. Using refresh tokens in the front end should be avoided unless a system of refresh token rotation or sender constraint is in place. So unless you try to rotate these refresh tokens on a very steady basis, you can use them, unless you do sender constraint, which is something that sounds very fancy in theory, but in practice that's not possible because there's just no way to do this yet. Some very smart people are thinking how to do this, how to implement this in browsers, but sender constraints is not really something that's out there in the open yet. So if you want to use refresh tokens at the moment, you need to have an identity service provider or an authorization server that can rotate your refresh tokens on a very steady basis. So just if they get leaked, chances are they will not be useful for very long because you will create a new refresh token over and over and over again. So, does this approach solve for CORS? Who thinks it does? I think it does, because a JSON Web Token is issued by an authorization server, but it's not linked to a certain origin, to a certain domain. As long as you know how to verify the signature, and as long as you know how to decode base64, you can use these JSON Web Tokens. So if I pass a JSON Web Token to all of you and give my public key to all of you, you all can verify the signature. You can see that it's still valid. You can use it. So it does solve the CORS issue. Does this approach solve for flow? Who thinks it does? Again, this JSON Web Token is issued to no certain domain or server or API specifically. Anybody that's in the audience of that token, if you're talking about access tokens, can use these tokens. So as long as you know how to verify them, if you're in the audience of your token, you can pass them along from server to server. That's not the best practice, but in theory you can do this. So it does solve for flow. And does this approach solve keeping state? Who thinks it does? And you can put your hand up or you can leave it down because both are correct. In theory, it does keep self-keeping state, but if you want to keep a blacklist of tokens you want to not accept anymore, you're keeping state again. If you want to do the silent authentication request in the background, you're issuing in a session ID and a cookie again, so you have to keep state. So in an ideal world, it would solve for state, but in practice, because there's too many clever people trying to misuse anything on the internet, you kind of have to keep some state anyway. So let's summarize. Using session cookies is hard with single-page applications, mainly because, of course, if you're using a single-page application and your API and everything you're using is on the same domain, same origin, you can still do it the old-school way with cookies, but if you use a lot of different APIs with different origins, you will run into problems very fast. So that's why token-based authentication can be a thing. Stateless authentication is possible, asterisk, because of blacklists, out of state. And JSON Web Tokens consist out of 3 different parts: the header, the payload, and the signature. If you want to know more, JSONWebToken.io. Our blog has a very good article about what's going on with the implicit flow, the easy auth flow, and why you should move towards the PXE flow, the proof key for code exchange flow, and why that's better. And it has a lot of other different interesting articles as well. If you want to see these slides again, jwt.sambego.tech. I'll leave them on for a second, so if you want to take a picture, go ahead. I'll tweet them later as well, just in case. So these slides are just on my website. Thank you very much. Do we have time for questions?
Yeah.
We have time for questions.
Push.
Okay. He's going to ask me a very difficult question.
You said at one point early on that you should expire your tokens. I think, I can't remember the exact term you used. Was it relatively or relatively soon? Are we talking seconds or minutes or hours or years?
Kind of depends on your tokens and kind of depends on your own requirements. I think access tokens for us expire after 10 minutes. A refresh token usually stays valid a bit longer. That's why you should try to avoid them on the front end with single-page applications. If you use them in other systems, they tend to be valid for a few days even. But access tokens usually, for us it's 10 minutes default. You can change this, but relatively fast. Yeah. Any other questions?
For the refresh tokens, you mentioned that it should be like revalidated or should be.
Yeah, there should be rotation, which means that if you use a refresh token, that token should expire and you should issue a new refresh token each time that the refresh token gets used.
So it's just the regular expire flow, not something that like makes them invalid at the server side or something like that.
No, it just means that your token expires either on a certain rotation schedule, or when it gets used, it's only used only valid for one time, and then you need to issue a new token. Just when it gets leaked, worst case, they can get one new access token.
Thank you.
Like this. Any other questions?
Okay. This one may be a bit stupid, but why there are access and ID tokens? What would be worse if there would be just one token?
Yeah, that's a very good question, actually. It's not stupid at all. A access token is specified by OAuth, an ID token is specified by OpenID Connect. That does not matter. The important part is an access token is meant for an API. So if you are an API, you want to consume an access token because it contains information which tells your API this user has access to these certain endpoints, these certain scopes. An ID token should never be used by an API. It's something that contains identity, which should be used by your front end, your single-page application, just so you can show the username or the gravatar or whatever you want. So access token, only for APIs, contains no usable information for a human, let's say. ID token, only for the front end, contains only some information about the identity of the user that's authorized. They're specified by 2 different standards. They're 2 different things, but it gets a bit confusing. So if you're working with APIs, access token. If you're using the identity on the front end, ID token. Does that make sense? You could put one part of data in both of them, but that's not best practice, and
Okay.
standards are standards. Yeah.